that's fine. What I want to talk about today is that, and that's fine, Connor, no big deal. I want to talk about 10.2. So 10.2, you'll see your homework is very, very minimal. There's something called the binomial theorem that you can probably learn about in pre-calculus. But 10.2 kind of goes back to one concept in 10.1 that I want to review, and then you'll kind of see how that builds on that. Okay, so remember on Monday, we talked about if you have R objects taken from N objects and repetition is not allowed, then the formula to figure out how many possible combinations, how many permutations it is N factorial over N minus R factorial. So that just sounded like a bunch of words that I just said right there, right? But what does that actually mean? So what it actually means is, I'm trying to think of a fun example. Our class is so small, so I can't pick on our class. I guess I'll still pick on our Algebra 2 class. So if we have 5 people, including me, in Algebra 2, right? In Algebra 2. And I want to know how many ways I can make up a panel of 3 people. Well, no, I know what it is. We're going to pick, let's say, we're going to go to a restaurant and someone gets first choice, second choice, and third choice. Okay, so how many ways can I have of the 5 people in our algebra class? How many ways can we have a person that gets to pick first, a person that gets to pick second, and a person that gets to pick third? So what you're going to use is you're going to use this formula in order to figure out how many different combinations there are. So we have N objects, N number of people, right? So we have 5 people that we can pick from, right? And there is 3 spots. So we subtract 3 factorial, and we end up with, so basically we have 5 times 4 times 3 times 2 times 1 over 2 times 1. So that means there are 60 different ways that we could have a person in first, second, and third picking a restaurant that we were going to go to. Okay, so we kind of talked about that on Monday. I think we talked about it in a more realistic example. When we have 12 students in a class, we need a president, a vice president, a secretary. How many combinations of these people in those 3 positions are there? Okay, I also mentioned that another way to state this is we have the number that, well, we could call this the NPR. Okay. So we have N objects picked from R. And I said it a little bit better on the call, but you can also do this in Desmos if you want to. Let's see, somewhere on here is Desmos. I don't know where you are, Desmos. Here we go. So under functions, statistics, NPR. So we have 5 students and we want to be able to pick them 3 ways. And what's going on with you, Desmos? I had this problem earlier. It didn't want to evaluate anything for me. Let me start over. I was trying to do a problem earlier and it just didn't want to do it. All right, let's try it one more time. Stats, NPR. So we have 5 people in the class and we have 3 positions. There we go, 60. Okay. All right, so the thing that I want to talk to you about today that actually does relate to this is, where's my paper? Here we go. What happens if the order we choose are 3 people or out of our group or however many people out of our group isn't important? Okay. So when the order is important, like we have someone that gets picked out first and they get to pick the first restaurant and the second and the third, or we have the president, vice president, and secretary. We actually care. Sorry. We actually care a lot about the order in that, and that's when we call it a permutation. Okay. There is something that we call a combination, which is when we select a number of things from a larger group, but the order doesn't matter. So in your notes, it's on 10-2 right here. Okay, and you can see all those words are right there. So I'll pull this over. Okay. So it's written nicely for you. So the difference would be, in this example, there's 5 of us in Algebra 2, including me, right? And we had somebody that gets to pick first, somebody that gets to pick second, and someone that gets to pick third. So what if we didn't care about a first, second, third? What if we just said we're going to let 3 of the 5 people from Algebra 2 pick where we go to lunch? That would be a weird thing to do. But if we were going to do that, we don't actually care what order that group of 3 is in. We just care that it's 3 out of the 5 people. So permutations is when we're picky, right? That's what it is. We have the number and we're picking a certain number out and we're picking it in a certain order. Instead of permutations, we're going to use something called combinations, which you can see that the formula looks really similar to permutations, except we have an added term in there. Okay, so when we have, 5 people in Algebra 2, and we want a committee of 3 people, but doesn't matter how you pick the committee. If you pick Connor, Josiah, and Kyla, like they are the first people that you pick, or you pick Kyla first and then you pick you, Connor, and then you pick Josiah. Like it doesn't matter which order you pick out those 3 people on the committee, right? So, sorry. So that formula is you have 5 people to choose from. Okay. You do the 5 and you subtract out the 3 people that are on your committee. And then you also multiply by the 3 people on the committee. So when I multiply this out, it's 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So cross out some stuff, right? 3's cross out. 2 goes into 4 2 times, and you end up with 10. So you can see when you're talking about a combination, you have less numbers, which makes sense, right? With permutation, we cared who do we pick first, who do we pick second, and who do we pick third. So there's a lot more different ways to come up with, even if you have a group of 3, which order they're in. When we pick combinations, out of 5 people, there's 10 different combinations of 3 people that we can make. Okay. And this is written the same way. You can see here, it's NCR instead of NPR. So again, Desmos will calculate this for you. And you could probably saw it right next to the NPR. So NCR, the number choose a certain out. So if we choose 3, there we go. We have 10 from that. So that was my cheesy problem with that. But a better example might be, again, from before we said the poorly worded problem here. From a class of 12 students, we need a president, a vice president, and a secretary, right? However, this problem says from a class of 12, we need to pick out 3 students from a committee for a committee. So how would we calculate the number of combinations? So there's 12 students, right? We have to pick out 3 of them. So you can see here that we would put in 12 for the number of possibilities, right? We're choosing 3. So 3 goes in for our R. So 12 factorial over 3 factorial times 12 minus 3 factorial. or 12 choose 3. And if we have 12 students in a class and we want 3 for a committee, there's 1,140 possibilities. Although I have that marked out, so maybe I did that wrong. Maybe we should double check that in Desmos. 12. No, I had that written wrong. So that's why. There's 220 combinations. That seems much better. I had it marked off. 220. Okay. If you go back and you look at problem number 2 in 10.1, when we had 12 students and we needed a president, a vice president, and a secretary, there was 1,320 combinations. And I guess, again, Desmos will verify that for us. Much better than I did on my math, apparently. So you can see being picky about the order makes a huge difference in the number of combinations that are possible. If we just want a group of 3 out of 12, there's 220 ways we can make that. If we want a group of 3 in a specific order, then we have, let's see, 6 times as many combinations, or as many permutations is what I should say. So that's basically 10.2 is a little add-on to 10.1. 10.1 is kind of the heavy section. 10.2, we're just adding in the fact that we can have combinations as well. So I am going, let me see. Oh, you guys don't have all the notes here, right? Your notes stop. Do you have the 10.3 notes? Okay, so I'm just going to do like a 5-minute intro to 10.3 and then I'll let you go and it'll be pretty fast today. Okay, so we're going to talk about probability and odds. Okay, so probability is just a measure of how likely or unlikely something is to happen. And probability is a number from 0 to 1. Okay, sometimes we also think of probability as like a percentage, but if you think of it as a decimal, it's always a number between 0 and 1. Okay, if something has a probability, probability of 0 or 0% probability of happening, then it's impossible. It's not going to happen, right? You hear this all the time. If something has a 50% or 0.5% or 0.5 probability of happening, that's like 50-50 even, either way. Okay. And then if something has a probability of 1 or 100%, then it is going to happen. There's no way it's not going to happen. So probability is pretty easy thing to calculate. Like if you're talking about rolling a die or dice, however you want to say it, right? What is the probability that you'll roll a 1 on a 6-sided dice? Well, there's one number 1 out of 6 sides. So the probability is 1/6. Okay. And you can see it right here. There's a 1 in 6 chance, which is about 0.166. So you're kind of on the unlikely scale, right? What is the probability in this picture that you will, if you have 5 marbles, what's the probability that you'll pick a blue marble if 4 of them are blue? Well, it's 4 out of 5. So there's a high probability that that will happen. Okay. So that is how we calculate probability, right? There's also something called odds, which is a little bit different. So odds actually are either the odds that something's going to happen or the odds that something is not going to happen. So odds are, I'm trying to think of an example off the top of my head. Maybe I have one on my paper here. I don't have a great example. So odds are a little bit different. So instead of comparing, like if I say, what are the odds that I will roll a 1 on a 6-sided dice? Let's just take that. Okay. So what are the probability that I will roll what I will roll a 1 on a 6-sided dice. So the odds versus the probability is a little bit different. So the odds would be, let me pull this over. Okay, the odds that I will roll a 1 are, there's 1 chance that I will roll a 1, and there's 5 chances that I will not roll a 1. Okay, the probability of rolling a 1 is 1 out of 6. The odds that I will roll a 1 are 1 out of 5. Okay, the odds that I will not roll a 1, the odds that I will not roll a 1 are 5 out of 1, because there's 5 chances that I'll fail and 1 chance that I'll succeed. So you hear odds, not that I want you to hear the word odds a lot, but you hear odds when people are talking about like betting. A lot of times you'll hear referred to odds versus probability. And so that's kind of the difference between the two. So in the case of the marbles here, right? The blue marbles. Okay, the probability of me picking a blue marble, the probability is 4 out of 5. Okay, the odds of picking a blue marble are 4 to 1. The odds of not picking a blue marble, or I could say the odds of picking, or yeah, we'll do the odds of not picking blue, are 1 to 4. So I just want to mention that that's kind of the difference between those two terms, probability and odds, and then we'll do some problems with probability and odds on Monday. All right, so that's all I have for today. Thanks for hopping on, Connor. I know it was a fast one, but make it easy. We might even do some more Chipotle stuff on Monday too.